This video gives an introduction to exponential functions. An exponential function is any function that involves a positive number other than 1 raised to a variable exponent. So that's really the key to exponential functions, is that the variable is the exponent. The most basic exponential function is f of x equals b to the x with b not equal to 1. And the constant b is called the base of the function, and the variable x is called the exponent of the function. Since the base is a positive number, the expression b to the x will always be positive. For large negative values of x, the expression b to the x will be close to 0. This creates something called a horizontal asymptote on the graph. This is a line that the graph gets infinitesimally close to, but never touches. So that word infinitesimally means very, 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 very close to, but never touches. For example, here's the graph of y equals 2 to the x. We would think of the line y equals 0 as the horizontal asymptote, and you can see that it actually looks visually like the graph is on the x-axis, but really what's happening is it's getting so close to the x-axis that it looks that way, but it's actually just slightly above the x-axis. And then over here on the right in the first quadrant, the graph just shoots upward very quickly. So this is the graph of y equals 2 to the x. The graph of an exponential function can be shifted, flipped, and stretched by using addition, subtraction, and multiplication by a positive or negative constant. For the following graphs, let's find the horizontal asymptote, the domain, and the range. So horizontal asymptote is the horizontal line that the graph approaches but doesn't actually touch. The domain is all the possible x values, and the range is all the possible y values on the graph. So let's start with this first one, y equals 2x minus 3. We're given the graph, and we just have to find the domain, range, and horizontal asymptote. So we can see visually on the graph that the horizontal asymptote happens at y equals 3. So I'm going to go ahead and write that down here. So I'm going to have horizontal asymptote and I'm going to go ahead and abbreviate that as capital H, capital A. So the horizontal asymptote is going to be the horizontal line y equals -3. So I'm just looking at that dotted line there. Now I want the domain and the range. So the domain is all the x values. So the domain, if I look at my graph, it looks like I can plug in any x value there and still have a valid output on my graph. So my domain is going to be all real numbers, which I would show in interval notation as -infinity to infinity. So my domain is -infinity to +infinity. That's all real x values, all real numbers. The range is all the y values. So you want to look at the range, the lowest y. We have that horizontal asymptote at y equals -3. But remember, the graph never actually touches that horizontal asymptote. So I want to go ahead and use a parenthesis to exclude the -3 And then I see the graph goes upward infinitely. So I'm going to have -3 to infinity. But remember that parenthesis excludes the -3. All right, let's look at the next one. We have y equals -4 times 1/2 to the x plus 3. So I'm going to go ahead and use capital H, capital A to represent my horizontal asymptote. And I look for that dotted line, that horizontal dotted line. And it looks like if I look at the counting here, that's at y equals 3. So this would be at y equals +3. The domain for this function is all real x values, so -infinity to +infinity. And then the range, if I look at the y values, there's no lower bound on the y's. This graph actually goes downward forever. So it would be -infinity. My upper bound is y equals 3. But remember, the graph never actually touches that horizontal asymptote. So I'm going to use a parenthesis on the 3. And the parenthesis means that that endpoint is excluded. So that excludes the 3. If I wanted to include something, I would use a bracket. To exclude it, I use a parenthesis. Here's our next one. Y equals 2 times 2 to the x plus 2. So our horizontal asymptote is the dotted line that's shown. And we can see that happens at y equals 2. Our domain is all real numbers. We can plug in any x value in that function and get a valid output. So domain is -infinity to +infinity. And the range, my lowest y value is 2, but it's not included. So I'm going to do a parenthesis 2, and the graph goes upward forever. So that's 2 to infinity. And remember, the parenthesis excludes that endpoint, so it excludes the 2. Okay, let's look at how do we graph exponential functions if we're just given the function. So to graph an exponential function by hand or in ALEX, plot 5 points and then draw the asymptote as a dotted line, and then connect your 5 points with a solid curve, making sure that your graph doesn't cross the horizontal asymptote. So the horizontal asymptote will be a horizontal dotted line, and we want the graph to get really close to that, but never actually touch it. So our first example is f of x equals 3 times 5/3 to the x. And what I've done is I've actually made a table of points here. On the next example, we'll fill in the table ourselves. But basically what you want to do is you want to choose some x values. 0 is a really great one to use. So when I have x equals 0, I'll have y equals 3 times 5/3 to the 0. And 5/3 to the 0, anything to the 0 is 1. So this becomes 3 times 1, which gives me a 3. So my first ordered pair is going to be at the point 0, 3. So I'll go ahead and plot that first. So I have the point 0, 3. My second x value I picked is x equals 1. So then I get y equals 3 times 5/3 to the first power. And if I put that in the calculator, that comes out as a 5. So my second point is the point 1, 5. So I go ahead and plot that point. My third value is x equals 2. So I plug that in as the exponent. So I get 3 times 5/3 squared. And in the calculator, that comes out as 8.33. So my third point is 2 for the x and 8.33 for the y. So I'm going to go ahead and graph that point. In ALEX, you would want to go ahead and use the point plotting tool so that you could get on the correct place. And I checked in the ALEX graphing, and if you just go ahead and round to 2 decimal places, it will count that as the correct point. It doesn't have to be exact. My fourth x value is -1, so I do 3 times 5/3 to the -1, and that comes out as 1.8. So my fourth ordered pair is -1, positive 1.8. And then my last x value is -2. So I have y equals 3 times 5/3 to the -2, and that comes out as 1.08. So my fifth ordered pair is -2 on the x and 1.08 on the y. So I do my best to plot those, and I'm going to have a horizontal asymptote on the x-axis, and so I just try to connect those with a smooth curve. And I've got the graph of my exponential function, f of x equals 3 times 5/3 to the x power. So you pick x values, plug them in as your exponent, get the corresponding y values, and then plot the ordered pairs. Let's do one more example where we have to actually make this table ourselves. So we want to graph the function f of x equals 8/3 to the -x on this grid. So what I want to do is I want to find some ordered pairs. So I'm going to pick some x values. So I'm going to go ahead and make the table for myself. So let's say I pick 0 first. I'm going to use the equation y equals 8/3 to the -x. And so when x is 0, I'm going to get y equals 8/3 to the 0. And anything to the 0 power is 1. So my first ordered pair here, my xy ordered pair, is going to be the point 0, 1. So I'll go ahead and plot that first. Now I want to pick some other x values. So let's say I pick 1. Then I'm going to have y equals 8/3 to the first power. And I want to get an approximate value for that. So I'm going to go ahead and pull up my Desmos calculator, and I'll put in 8/3. And I don't really actually have to put the first power because the first power is just going to leave me with the 8/3. So that's going to be 2.67. And I'm getting the approximate y value so that I can actually plot it. So I'll have 2.67. So my second ordered pair would be the point 1 and 2.67. And actually, I did that wrong because this should actually be a -x, so -1. So let me actually redo that. Apologies. And let me actually give myself a little more room here when I'm calculating these. Okay, so I want to actually do 8/3 to the -1. So in my calculator, I'll put in 8/3, use the exponent key, the A to the B key, and then put in a -1, and we get 0.375. So I'll have 0.375. So my ordered pair is 1 and 0.375. So I'll do my best to plot that. It would be down here somewhere between 1/4 and 1/2. And let me get another ordered pair. Let's say I have x equals 2. Then I would put in y equals 8/3, and it's 8/3 to the -x. So this would be to the -2. And I want to go ahead and put that into my calculator. So I'll do 8/3 to the -2. Okay, so I do parentheses, 8 divided by 3, use my right arrow to get out of fraction mode, close the parentheses, do the exponent key, A to the B, and then put a -2. So I get 0.1406. 0.1406. And so my ordered pair would be 2, 0.1406. And that would be way down here. That's almost at 0, but not quite. Okay. Now I want to pick some values of x that are to the left of the y-intercept. So let's say I did like -1. Then I would have y equals 8/3 -1 would give me a +1 here. And that was the one that we did earlier that we found was 2.67. So I'll have the point -1, 2.67. All right, and then one more point. Let's say I do -2. I'm going to have y equals 8/3 to the -2, which would give me a +2 up there. So I want to do 8/3 squared. Okay, so I do parentheses, 8 divided by 3, close the parentheses, get into the exponent and square it. We get 7.11. So I'll have 7.11. And so my last ordered pair would be -2, 7.11. And you can see the graph is growing very rapidly to the left. So -2, 7.11. And I want to do my best to connect those. So I'm going to come down. It's a very steep graph here. And I want to connect in a smooth curve. The Alex graphing calculator will actually connect these for you. And I have this horizontal asymptote at y equals 0. And so if you wanted to graph the horizontal asymptote, what you would do is you would just select a dotted line. Let me grab a dotted line there. And you would actually draw it in to show that the graph doesn't actually cross there. So this would be the graph of f of x equals 8/3 to the -x, and the horizontal asymptote y equals 0. So again, we're just picking x values. We're plugging them into the function and using a regular calculator to get the corresponding y values. Plot your ordered pairs and then connect with a smooth curve. Let me go back to this example where we did f of x equals 3 times 5/3 to the x power. If we wanted to graph our horizontal asymptote, we would select the dotted line tool and draw in a horizontal line. So we have a horizontal asymptote at y equals 0. We had our 5x values. We plugged them in for the exponent, and we got the corresponding y values, plotted the 5 ordered pairs, and then connected. So that's how you graph an exponential function.